Yes, you must have seen these kind of plots in the popular science newspaper or article, or in case you are a physics or astronomy students. So these kind of plots are called inset plot. So these kind of plots are used to visualize your data in a very finer region. So here you can see that this is one of the spectrum from a spectrograph, uh, which is installed on Sloan Digital Sky Survey Telescope. So you can see this is the flux versus wavelength of an object, and this is the spectra. You can see some lines, right? Some lines, emission and return lines, and you can see these red patches are the region of the spectra, and this this region, the the top left, top right, and this the center one is the zoomed version of the spectra of this red shaded region. Okay, so this can be used to visualize your spectra in a uh, much finer way or in a better resolution. Okay, here you cannot see the features of this spectra, like which lines are present, but like once you make a inset image, you can zoom this spectra and you can visualize better way. So similarly, you can also see this image. This image is like a large sky region, in which you can see there is some smaller region, and you can see the zoom version of this image is this inset image, in which you can see the objects in much more finer and in uh, in better resolution. Okay, I mean, you can at least you can visualize its substructure and a structure. So what I'm going to do in this tutorial using Python coding and Astropy, and I'll be using FITS file. I am going to uh, plot inset plot for a spectra of a galaxy. Okay, so this is my galaxy spectra in the blue plot, and these red patches are my selected region to zoom, and this subplots in the green, red, and this cyan color is its inset plot corresponding to the red patch of the spectra. Uh, this inset plot represents a smaller plot inside a larger or the main plot, and it provides additional details or a different perspective to the data analysis and your visualization. So basically, it is commonly like used for zoom in on a specific region of interest of the image or a spectra, or like show a different variable related to the main plot, or like you can also like use for a comparison between like different scale, linear, log, or any kind of a scale. So in order to create such inset plot for the astronomical spectra, I have gone through some following steps. So total will be doing this coding stuff in 8 steps, right? So a step 1 will be to download a galaxy spectra. After that, I will import some necessary or required library, and after that, I will read this FITS spectra using Astropy, and then I will extract the spectral data such as flux, wavelength, and redshift in case I have to go to the rest frame of the spectra of the spectra, and then we will visualize galaxy spectra. I mean, on y-axis there is a flux, and on x-axis there is a wavelength range. After that, I will define a zoom-in region of spectral lines to create inset plot of that region, and after that I will extract the relevant data range of flux and the wavelength, and then I will plot these extracted region in a inset plot. So this 8 step we are going to follow it. So let me go to the step 1. So our step 1 is to download a galaxy FITS spectra. So I'm not going to show you that how to download the spectra, because already I have created a tutorial that how to um, download FITS spectra. So here's my link. Okay, here's a link to the YouTube tutorial, and I will attach this link in the video description, or you can just click on the top right corner and you can find this tutorial link, right? So let me click here in case if you want to see. So here this is. So here's the title, right? So you can go and just download these spectra with this, right? So now come to a step 2. We'll import our required library. So first we will import numpy as np. So this deals with numbers and array. Okay, and then I can import matplotlib for plotting and visualization data dot pyplot as a plt, and so this is with your data visualization, and after that I can import Astropy. So from Astropy dot input output import of FITS, right? So this deals with FITS file. Okay, and after that you can import your inset plotting. So from mpl underscore toolkits dot xs grid1 dot inset locator import inset access, right? So these things we need to import library. So this is for inset plotting, right? Now step 2 is completed. Now come to step 3. So I hope you have downloaded your FITS spectra by watching my tutorial given in the description link. So now read FITS file. So I can open my file first. Okay, so I can give here stdu equal to, just call here a file equal to fits dot open, and give here file name. Okay, so in my case I have this file name. Spectra.fits, right? So this basically what it does. So this reads your uh, fits file, right? And then you can like extract the file information. So like what the file contains. So this will give a file information, right? So if you look at here, you can see I have 3 SDU and my data is in like this second, okay, bin a table SDU like which contains this much rows, a column, so data format and other stuff, right? So let's extract my data, okay. Here you can do one more thing, like you can go to your go to this SDU code SDU. So just you can just go here, SDU equal to a file, right? File or file and then go add, right? And then type here dot uh, okay. So dot header, okay. So header and see what it is printing. So if you see here, you can see it's expression is bin double SDU. We have say flux and we have your log lamp, okay. So basically your wavelength is in the log scale, okay. So this is how you can extract this information, and after that you can extract data, okay. So now um, extract data. So for that type here data equal to okay. So just copy this file one, then give dot data as an attribute, right? So if you want to like extract wavelength, so now extract here a wavelength, right? So wavelength. So for that type here a log, okay, log of wavelength, right? Log of wavelength. So for that type here data and give a square bracket and give your variable name as a log lamp, okay. So give this variable name log lamp, right? So if you print here log wavelength, this is your wavelength, okay, right? And similar in the similar fashion you can also like print your flux, okay. So extract flux. So type here flux equal to your flux equal to uh, your data, right? Data and data, and you can give a square bracket and give this your keyword called flux, okay. So give keyword flux So if you see here flux, print it. So this is how it returns. Okay, and here you can like print your data also. Okay, so if you give here mm, if you give here the data, this variable, see what it is printing. So it will print a lot of stuff, right? So you can see the flux, log lab, mask, and model of the fitting, right? So right now we have to care only about this wavelength and flux. Okay, so here the flux is in the like log scale. So we have to convert this flux into your linear scale. Okay, so go here and type here wavelength. Okay, wavelength into 10 raised to your log of wavelength. Okay, so this will come in a linear scale. Okay, so this becomes your wavelength in linear scale, and this is in the log scale. Okay, so here your wavelength in the log scale, right? Now we have successfully done the uh, step 3. Okay, right. So till we have completed our step 4, we have extracted the data, flux and wavelength, right? Now we'll go to a step 5 and visualize our galaxy spectra. I mean flux versus wavelength. Okay, so let's create main spectra, right? Main spectral plot. So I can first create a figure and axis. So type here figure comma ax equal to uh, plt dot subplots, right? So subplots and see what it takes. So basically it takes your uh, figure size and some yeah. So for timing I'll give only figure size, right? So I can give a figure size, say fig size equal to, I can give 15 is to 10, right? And so this is 5. So this is here. I have created a canvas for plotting my uh, spectra, right? So you can see I have normalized x and y axis, and this is a canvas in which like we can plot our spectra. So for that I will uh, I will uh, I will give a plotting command. Okay, so plot it. So plot it. Type here x dot plot, and then you can uh, pass your wavelength and flux. Okay, so give here so wavelength on x and flux on y-axis, right? And yeah, so and then type here uh, priority dot so, right, and run it. So here you can see that I have this spectrum of the object, right? You can see this is some lines going on above and some lines going downward, which are so positive flux represent your lines represent mission lines, and negative flux represent your exhaustion lines. Okay, so you can see here you have this each alpha line is most prominent, and there are some O2 lines, N2 lines, and uh, okay. So yeah, so let me uh, give some label to this. Okay, so for visualizing, so you can give here uh, x dot set underscore x level. Okay, so x we have wavelength, right? We have wavelength, and this is in the angstrom unit, right? So for that type here, and right, so this is the LaTeX format. So I think there's some mistake here. There should be, yeah, I think there should be dollar sign. I think there's some mistake here. Yeah, yeah, now it's fine. Okay, so we have this uh, wavelength in angstrom unit, and then you have say uh, you can set your y um, axis level, and just type here y axis level and just call it flux, right? So flux, and you can type here title, so x dot set uh, underscore title, so you can call here SDSS Spectra, right? And so this is how things look like, and you can also give the font size. So font size equal to 30, and you can give same font size to your all. Okay, so now my spectra is ready here in the blue color. Okay, now I'm going to define some zoom regions, say suppose around this each alpha region, and some at the edge, and also on some like outer edge on the right side. Okay, so for time being I will do for this inch alpha line the most prominent line going up to 25, and then I will use for loop to do multiple inset plot in the different regions of this spectra. So let's do it. Okay, so uh, what I can do, I can now uh, I can now define region. Okay, so come here. So define zoom range. Okay, so call here zoom range. Okay, zoom range, and you can give say okay, so you can see here like how much goes your uh, this wavelength axis. So it goes from around 3,000 to around 10,000. So I can choose some lines, right? So I can choose from say 3,000 to uh, just go up to 6,700 to 6,800. Okay, around this region, right? Now we have choose one region. Now I will uh, I will give say yeah, leave it. We will give later color and or stuff location. Now I will like extract the relevant data within that range. Okay, so for that type here zoom called here zoom wavelength. Okay, zoom wavelength called zoom wavelength equal to mm, type here wavelength and uh, extract from its minimum and maximum values. Okay, wavelength and then extract, give a square bracket and type here wavelength greater than uh, zoom range. Okay, so this would be like greater than this, and then give your AND operator and uh, give again bracket wavelength less than zoom range 1. Okay, so zoom range 1. So if you print your zoom wavelength, so what is mistake here? This would be wavelength. Okay, so this is how it looks like. It goes from 6,700 to 6,799. Okay, so I mean in that range. Okay, so uh, in the zoom range. Okay, now I will extract the flux also. Okay, so this is my wavelength, right? So, mm, so this is my wavelength extraction. Wavelength extraction for inset, and then I will extract corresponding its flux. Okay, so inset flux extraction. So for that I will type a variable zoom flux. Okay, zoom flux equal to flux, right? And you can uh, give your like sim. Okay, the sim the same variable, copy it, and just do this and type here flux, right? And yeah, so for that, yeah, so that will work. Zoom, there should be double O, right? Now if you print the zoom flux, see uh, how it looks like. Okay, now we have extracted our data. Now I will be doing uh, preparation for plotting the inset plot. Okay, so now plot it. So for that, create here inset, okay, variable, inset variable, and then give your inset axis, okay, inset axis, and see what it takes. So it takes a lot of stuff. So first it takes your parent axis, okay. You can give width, height, location, and some other stuff you can give. So you can give your parent axis as a x, okay, and then you can give some width. Width, I mean, give say 40%, right, of the size, and you can give height. You can give height equal to say height equal to 30% of the figure, right? Let's see what it turns if you type here inset, right? So it's just an object, right? Now I will plot it, okay. So now plot inset. So for that type here inset dot plot, right, inset dot plot, and I can give my zoom wavelength and my zoom flux, okay, right, zoom flux, and you can give some color, right? So yeah, so give color equal to say red, right, and then type here prt dot show, right, not visible, so I think we need to do um, I will create this inset plot by this zoom wavelength and zoom flux, okay. So for that, type here a command, uh, okay. So type here your inset variable and insert the axis, right. So insert axis and see what it takes. There should be insert underscore access function, right? And see what it takes. So it takes your parent axis from the plot, width, height, and location. Okay. So for just time being, I will type here my axis, right, from here, from above plot, right, this x, and after that I can pass the width and height parameter. So width equal to say 40%, and you can also mark height equal to 30%, and give some locations, and you can give location equal to say upper right. Okay, upper right. So let's see what it returns. So basically it returns object, right? And then you can plot it. Okay, so for plotting, type here inset dot plot, right, and you can give your say zoom wavelength, and you can give your zoom flux, right. Run it, and then type here plt dot show. Okay, so nothing has returned. So go to above code and copy these two commands, right, and come back and just put here, right, and plot it. So here you can see that I have this inset plot. Okay, so this is my original spectra, and this is my spectra in from 6700 to 6800 range. Okay, now like how to like show this region using marking. Okay, so for that we need to import one library. So go on the top where you have imported library, and put here mark inset. Okay, run it and come to the step 8, right, and you can mark here, say you can give mark inset, right, and you can give say x, you can give inset, and you can give some location 1 as a 1, or just give 3, location 2 as 4. Okay, location 2 as 4. Now run it. So here you can see that you have showing this region. Okay, so the so the here the meaning the 3 3 and 4 corresponding to your like lower left and the lower right portion of the um, uh, this your box. If you change it to 1 4, see how how things will change. 1 2, you can see this time it has connected from the top. Okay, so I will make it as a 3 and 4, right? 3 and 4. So this is how my things look like. You can like also give color. Okay, so you can give here, say, see what it takes. This takes color and other, and then you can change, you can give it to this, see, FC, right? So you can mark it as a red. See, this patch of area has been marked with red. Okay, then you can give one more, you can give EC, so it will change, uh, you can make it as a black. So you can see this line has been marked with black. You can mark with green, right? You can also like change its line width equal to 5, right? And so make it 3, and you can also give line style equal to dash. There is extra, yeah, okay. So this is how you can visualize. Okay, and you can also like give the Z plot as a color. So you can give, say, color equal to you can see K, right? Okay, what I have done, I have given that color to a different in different code. Okay, so you need to give here this color equal to K, right? So here you can see that I have this plot, right? And we have this portion, and we have zoomed this portion in this plot. Okay, so this is how a inset plot is made uh, from the main plot. And now you can visualize its substructure. I mean in the subregion of this spectra. You can see this is H alpha line, this is N2 line, this is the N2 6584, and this is 6548 as a doublet. So this is in the like your observed frame. So if you go to the rest frame, this will be come as a 6564 angstrom as H alpha, right? So now this much we have done. Okay, uh, and like now you can also like set these limits if you want here, right? So you can set these limits if you want, as a, say, inset dot set underscore y limit, right? So y limit you can do it, right? So y limit you can give it, say, I want 0, like, or just go from -10, 0, 10, 20, 30, 35, right? What is the mistake here? mm, yeah, so there should be from 10 to 35, right? So this is how we can change it, right? You can also like give a title if you want. So just type here inset dot set underscore title, and you can say zoom uh, spectra, right? So this is how it will write. Okay, so I hope you got the idea that how to control these aspects, right? You can also like change its location, say upper right. You can mark it say center, right? Here should be here, not okay. So it comes here, right? So make it as the earlier one, upper right, and then I can change this aspect ratio, say 50. So this is how to change, and if you make it say 40, so this is how things will change. Okay, so make it as a 30, right? So you can see the uh, whole zoom. Okay, this is how things are done. Okay, so now I will be next, like I will be doing for multiple zooming regions. Okay, so I hope up to this point everything is clear. Now we have successfully done this insert plot for a single region. Now we are going to next step 9, in which like we will do multiple insert plot. Okay, so for that I will like use the previous code. Okay, I will not do much coding. So what I'll do, I will like choose my zoom region again. Okay, and this type like multiple. So I will just choose like uh, three regions, right? So called zoom region 1, and then second one, uh, you can you can choose from the spectra as a say 4900 to 5200, right? And then third one you can choose 60 to 100 to 6400. Okay, and then make it as a okay. So there are zoom ranges, and then you can define some colors for like each plot. So colors equal to, can make RG and B. Okay, and then you can set a location. Okay, so that they don't overlap. So locations equal to, you can give say uh, upper right, then upper left, right, and then you can give the lower center, right, lower center. So like we have three locations, nothing is set. Now I will do the uh, inset plotting. Okay, so inset plotting, and extract extract a wavelength and zoom flux. Okay, so for that I will use for loop. So for I and then go to the zoom range, right? Go to the zoom range, um, then like crop till all things together, zoom range, colors and locations using in enumerate and then pass the zoom range, right? Give the column and then you can give your for your location and color. Okay, so give color equal to colors of I for your each plot and then location equal to locations of each plot, right? What is the mistake here? Okay, upper right, upper left, just make it center. There is a mistake. Locations, RGB, locations. Oh, there should be equal to, not minus, right? So there should be equal to. Now finds things are looking good. Then insert inset plot. Okay, so for that just go to my real code here and copy this two codes for the main plot, right? This is my main plot, so put my main plot on top of that. Okay, so put main plot here. This is my main plot and then go to the code once again and use your insert plot coding part. So copy this code, come to the step 9 and put here. Okay, and then you need to give the right space using tab for the for loop, right? Now this much is okay. So you need to like change your colors equal to color, right? And then you need to color equal to color and then location equal to location, right? Now run this. What is the mistake here? There should be ER. There is some mistake here, I think, in the giving the location. There should be ER, okay, not RA. Now fine, okay. So here you can see that you have like 3 plots. Or maybe you can also give a middle center if you want. Let's see how it works. middle center. No, there is mistake here. There is upper center, center, lower center. Okay, so we put a lower center. Mm, Lower center, right? So lower center. So now things are fine, and here you can see that you have these three regions. Okay, so I think this is like I have forgot to mark inset. Okay, that's yeah. I think it's looking good. Mm, then I give the different colors. Okay, so you need to set some axis level because you cannot visualize the stuff here. Let me yeah. So let me change its y. So inset dot uh, you can give you can like adjust its white ticks, right? So inset dot set underscore y white ticks, right? So white ticks you can set it as a mm, like just put it yeah, like that, or maybe just put upper center, right? This upper center. So now you can see, I think you need to change the range if you want. mm, this make it say 3000 to 3200. Yeah, so mistake because it is plotting three plots for the same region. So let me what means. Okay, so I have not appended this uh, zoom wavelength and zoom flux for different regions. So let me go to the above and yeah, so zoom wavelength and put it here, and then for zoom flux also. mm, Zoom flux also. Now run it. What is happening here? Maybe 60. Yeah, so now it is looking much finer details. Okay, you can see like we have three spectra and like all are like looking differently. So you can also like change the region if you want. So just make it lower center. So this is how it looks like, right? So this is like how you can like make multiple inset plot, and how you can do the stuff. Make it offer, and you can change the location of these plots, right? So this is how you can plot the cell plot for like different regions. So I hope you got the ideas. So let me review the code once again. So I have these steps. I have imported libraries, and I have then read the spectra. I have extracted the flux and wavelength. Then I have like plotted the spectra, and then I have done the single zoom plot for the spectral lines. Then I have like use the insert plot for a single region. Then I have used the for loop to insert multiple insert plot. Right. This is how it looks like. So thank you, and let me know if you have any doubt regarding this coding. And thank you. Stay tuned for the next videos.